Hello and welcome. My name is Lewis Weaver and I'm a software engineer at Facebook Reality Labs. My team handles our VR input APIs for developers, and my personal main focus is improving hands interactions and latency. In this video, we'll take you step by step through configuring and enabling hand tracking in Unity with the Oculus OVR plugin. We'll also help you enable basic gestures like pinch to select, and we'll discuss potential pitfalls to avoid when implementing hand tracking with Oculus Quest. Here's what you can expect to take away from this tutorial. You'll have an understanding of the broader context of hand tracking and be able to identify potential opportunities for implementation. You'll be able to identify common implementation options for hand tracking. You'll have an understanding of the limitations that come with hand tracking. You'll configure hand tracking with Quest and Unity. You'll learn how to create interactions with a world space UI using Raycast and Pinch. And finally, you'll understand how to create interactions with objects in the 3D world. Hand tracking brings with it unique possibilities for deepening immersion in VR. It allows you to interact with virtual objects and worlds with some of the most intuitive controllers of all, your hands. The first time you interact with a virtual object with your own hands, it adds a new layer of immersion, and you can feel how it draws you even more deeply into those virtual environments. As developers, it is especially exciting to imagine the possibilities for human hands as a starting point for interaction. How might we think about utilizing hands in virtual spaces? What types of new interaction mechanics, locomotion methods, or interfaces might we create with hands as the input? In addition to interesting and novel ways of interacting with games, hand tracking has enormous potential for enterprise applications, training simulations, and social environments in VR. For productivity or remote collaboration applications, hand tracking can help create compelling telepresence. It can help make your avatar more expressive and enable more precise interactions like drawing a note or typing on a virtual keyboard. Hand tracking is cutting edge, and we're just scratching the surface of what is possible. Developers around the world have already begun experimenting with novel interactions and potential use cases using the Oculus hand tracking SDK. We hope you will join in. This tutorial explores these possibilities by discussing commonplace implementation options, best practices, and some common pitfalls to avoid when implementing hand tracking in our VR applications. As we've just discussed, there are many potential benefits to using hands instead of physical controllers in your app. But of course, any new technology brings new challenges to keep in mind, which we'll discuss in more detail in the next section. As you start thinking about your hand tracking implementation, it's important to consider many different participant types in order to create accessible, immersive experiences. As an example of experimental technology, Waltz of the Wizard created a way for users with missing fingers to use hand tracking in their application. Depending on what your application is, it could make sense to provide users with an option to use a single hand instead of two hands. The VR game Elixir offers users a single hand option. The developer issued this update in response to a Paralympics member of Team USA who let them know she could not access Elixir because it assumed users could use two hands. Moral of the story? It's a good practice to consider accessibility from day one. Adding other control options that work alongside hand tracking can be a step towards creating an inclusive VR application, as well as providing users a choice of controllers or hand tracking as input. Hand tracking deepens the level of immersion people experience because it's their actual hands interacting with objects in the virtual world, not controllers simulating these interactions. It can also help broaden the audience's ability to interact with your application. Many will find hand tracking to be a more intuitive means of interaction than controllers with buttons, grips, and joysticks. Hands are also powerful social communication tools. When interacting with other people's avatars inside of virtual applications, hand tracking allows people to express themselves with the same gestures they might use in real-world interactions. This not only deepens their immersion, but adds enjoyment and realism to virtual conversations. There are a few important ways we can think about implementing hand tracking into our applications. The first implementation of hand tracking in VR we'll discuss here can be utilized for a large number of interactions. We here at Oculus commonly refer to this as Raycast and Pinch, which is pretty much what it sounds like. When you implement Raycast and Pinch, a ray will cast from a point just below the user's palms. To trigger an interaction, the user will then pinch their index finger and thumb together to cause the interaction. If you've already played with hand tracking enabled inside of Oculus or used the Hands app, this is the first interaction you experienced. Another powerful use case for hands in your immersive app is allowing people to interact with 3D objects in the environment. One obvious interaction is simply picking up objects in the virtual world. To create this for people using our apps, we can configure a varying degree of custom poses to align with our specific needs. Our goal is for these poses to feel natural for people. Therefore, they should emulate how someone would pick something up in the real world, unless there is a clear reason motivated by the experience to deviate from these expectations. A lot of applications actually just use pinch as a way to pick up a smaller object. This is because picking something up between your finger and thumb generally feels natural, and tracking the pinch interaction is relatively easy within the API. The neat thing about the Oculus implementation in Unity is that it provides developers with the ability to check whether each finger on the player's hand is or isn't pinching. You can then use this data to trigger interactions based on which fingers should be pinching. Take the example of a teacup. For users to pick it up by pinching the handle, you can tie that gesture to pinches by the index, middle, or ring fingers. Pinching with any of these fingers would snap the cup to the user's hand so they could sip virtual tea. To create these custom gestures, you'll want to familiarize yourself with the common methods for Oculus hand tracking. For pinching interactions, you'll spend a lot of time writing interactions with the getFingerIsPinching method. This method takes in a hand finger enum value that is used to specify the finger to query. Supported hand finger values are handfinger.thumb, handfinger.index, middle, ring, and pinky. GetFingerIsPinching will return true if the specified finger is pinching, or false otherwise. Along with these methods for tracking which finger is pinching, you can also look at the tracking confidence and whether or not hands are tracked. This can be done with the hand confidence method and will return either handconfidence.low or high. Using this method, you can validate if the confidence of hand tracking is high enough to make accurate interactions in your world. You can also check the Boolean method is tracked, which, as you might guess, will return true if the hands are tracked. It is recommended that you only allow object-related interactions when hand confidence is high and is tracked returns true. New technology like hand tracking is not without potential pitfalls. It's important that, as developers, we do our best to implement methods to address these pitfalls in order to minimize the risk of obstructing immersion for users. It's impossible to know every interaction issue that could arise in your application, but by knowing the broader categories, you have the best chance at implementing safeguards and solutions effectively. The first thing to be aware of with hand tracking is the more limited range of hand movement compared with controllers. Where controllers are tracked by cameras as well as internal electronics that can report the relative position, hands are tracked only using headset cameras. Therefore, with controllers, people can reach out at their full arm span even if they leave the camera's field of view. But hand tracking requires that the hands are within the field of view of at least 2 headset cameras. If the hands move too far left, right, up or down, they risk escaping half of the camera's field of view. Note that this is technically also true for controllers. However, since they are also equipped with internal electronics that report the acceleration of the controllers, it mitigates this issue. Your hands do not have the capability to give the headset acceleration and tracking data, and for many people, stretching out their hands to a full extension causes them to leave the camera's FOV, and therefore, the hand loses tracking. Another common pitfall is the issue of fingers being occluded by other parts of the hand. Finger tracking with hands is reliant on the camera seeing the finger in relation to the hand and then calculating the proximity and whether or not it's pinching. Therefore, tracking can be difficult for OVR in specific poses that may seem quite normal for a user. A few examples include making a fist after a punch, with the arm fully outstretched with the back of your hand facing up. Some or all parts of the fingers will be occluded, or both hands touching each other, whether clasping or simply bumping together. Notice when this happens, your hands generally both disappear. Or a pose that would require a two-handed grip, with the left hand in front of the right hand, or vice versa. This could include a boxing stance or an archery pose. These examples demonstrate that certain poses may not work using the current generation of hand tracking, and you would therefore want to design around them. Holding an object with two hands, for example, would cause your player's hands to touch, and they would lose tracking. So you'd want to make sure all objects in game were either single-handed only, or large enough that there was space between both hands. With any example, there are multiple possible solutions. In the punching example, you might consider allowing shorter, slower gestures to cause the punch to occur, or think about similar gestures where all the fingers are still visible. The important point to remember is that we always want to avoid breaking immersion. It won't matter how neat the hand tracking is if it drops repeatedly, ruining the experience for users. Hand tracking is also less precise and not as fast as tracked controllers. If your application requires precise tracking of rapid movements, you may want to consider using controllers instead. You should also take into account something that sounds obvious, but is worth noting. You can't currently send haptic feedback to users through their hands. So, if you want to create an app that uses haptics for notifications, or even potential accessibility options, hand tracking is not the best option. For example, if you want haptic feedback when swords clash, or when a flare gun fires off, controllers could be a better option. While the next item isn't necessarily a pitfall, it's something we all need to be very aware of. Every person will make gestures differently. This is important because it means that not all of your users will make the same gesture in the way that you expect. So, when implementing custom gestures, it's of the utmost importance that you test it on a wide variety of players to ensure that it's an effective gesture for a wide audience and not just for you and your dev team. Some gestures are perceived and used differently by different cultures, so it would be a good idea as well to verify you aren't asking players to make potentially unwanted gestures while playing. And of course, adding a tutorial or tutorial options for different gestures is always a good idea. Now that you understand some common hand tracking methods and general implementation ideas, let's take a look at the train demo provided with the Unity Oculus integration for examples on how we can set up hand tracking within our application. To open the scene, navigate to Assets, Oculus, Sample Framework, Usage, and open the Hands Interaction train scene. This scene has a completed demo of a train moving around a track that you control with various buttons. While there are quite a few different pieces tied to this implementation, the main items we want to focus on here are the hand tracking components, and how interactions are translated between buttons and hands. First, let's take a look at the hand tracking itself. In the hierarchy window, expand the Hands Interaction train scene, and then expand the OVR Camera Rig prefab. Inside, you should see a tracking space. Go ahead and expand this as well. This should have 6 parented objects: left eye anchor, center eye anchor, right eye anchor, tracker anchor, and the left and right hand anchors. If you've developed for Oculus within Unity before and have used the standard controllers, you will already be familiar with this setup. Just as it would be with controllers, the OVR hand prefab should be a child of left hand anchor and right hand anchor respectively. You can use the same prefab for both, and we will be creating prefab variants to identify the left and right hands. Expand the left hand anchor and click on the OVR hand prefab, and let's take a look at the Inspector tab. The first component attached to this is the OVR hand script, and it has 2 options that you can control: the hand type and pointer pose route. Notice the drop down for hand type is set to hand left, which makes sense as this is the OVR hand prefab underneath the left hand anchor game object. The next component is OVR skeleton, where the skeleton type is set to hand left, matching that of our OVR hand settings. This is how you should configure yours as well. In the first section, we referenced that the confidence behavior can be used to determine how well hand tracking is working. Changing the value set for the confidence behavior in the OVR skeleton renderer component tells Oculus what to do if the hand tracking confidence is not good. Right now, if that happens, the renderer is toggled off. This is what is creating the disappearing effect that you will see when you clasp your hands together or they go out of the frame. The data is now bad, so the confidence is low. You can set this to none, which means it would render regardless, but that may cause some inconsistent hand tracking behavior for your players. Something to consider when setting the renderer to none is what will happen if tracking is lost while an object is being held by the user. Depending on the goals of your app, you may not want to cause the object to drop every time tracking is lost. You could then track confidence while objects are snapped, and even if confidence drops below the threshold to toggle off the renderer, leave the object snapped in place. A final component that you will need to configure is that you need to set your mesh type in the OVR mesh script. This, just like the skeleton and hand, gives you the option to select the hand that this object belongs to. In this case, it's our left hand. If we pop open the right hand anchor and take a look at the OVR hand prefab that is the anchor's child, we'll see an identical setup. The only difference being, of course, that it's set to hand right instead of left. Once the prefab is configured this way, your hands will begin tracking within Oculus through Unity, and you should be able to build and deploy your application to test. In order to build your application for testing, you need to work through a few steps. First, navigate to File, Build Settings, and make sure your platform is set to Android. If this is not the case, update it and wait for the appropriate files to download and install if needed. Then, when you set the hand tracking support field on the OVR Manager script, which is located on the OVR Camera Rig prefab, to either hands only or controllers or hands, the Android manifest.xml file will have some additional tags with varying options added to it. When hands is enabled, Oculus automatically adds the users-permission and users-feature elements in the Android manifest file. These elements will contain a few attributes that let the manifest know if you're using hand tracking and if it is exclusive or switchable between controllers and hands. The user's permission element contains the Oculus hand tracking attribute. The user's feature element contains two Android prefixed attributes, name and required. The name should be set to oculus.software.handtracking. Required is a Boolean value that is set to false if the app supports controllers and hands. When false, the app prefers to use hands if present, but will continue to function with controllers in absence of hands. When the app supports hands only, required is set to true. The full details of these permission elements are available on our online documentation. Now that we understand how to implement basic hand tracking, let's touch on the Oculus sample framework and how it utilizes colliders in space to represent volumes when interacting with physical objects. If we expand Scene Setup in the hierarchy window and navigate to Near Field Items, all geo, we'll see the various buttons the players of this simulation have access to. If we expand that out, we'll see a few children of the various buttons. Let's start by looking at the Smoke Button Housing game object. Notice that there is Button Proximity, Button Contact, and Button Action, and each of these have a collider with a different size to gauge the distance to the button, and also to trigger a behavior relative to each distance. We'll take a deeper look at this later for our world-space interactions. In our next use of the sample framework provided by the Oculus integration in Unity, let's take a look at some of the other tools to integrate Raycast and Pinch more easily than if we wrote the implementation ourselves. In the root of the hand interaction train scene in the hierarchy, select the Interactable Tools SDK driver. This game object has two components, an Interactable Tools creator and an Interactable Tools input router. The two of these work together to make sure any interactions are processed and used accordingly in the application. You'll notice the Interactable Tools creator has two serialized arrays that you can add objects to. These arrays are labeled as left-hand tools and right-hand tools. And just in case you're worried that this isn't as obvious as it seems, the left and right-hand tools arrays are responsible for containing tools that need to be assigned to the left and right hands. Notice that each of them in this sample have a fingertip poke tool index and a ray tool transform associated with them. If you wanted to use different poking fingers in your project, you could simply add any of the other fingertip poke tools from the prefabs folder, located in Assets, Oculus, Sample Framework, Core, Hands Interaction, Prefabs. Each array stores transforms of objects that are associated with tools. For the purpose of this tutorial, we will be assigning fingertip poke actions to the index finger and casting a ray from each hand using the ray tool. The ray tool prefab has the ray tool component, which defines how the ray tool should function and cast a ray, and the ray tool view script, which is a field on this component which renders a line from the player's hand to the ray's destination. This is also the tool that causes the line to bend and curve elegantly between the object it is snapping to and your hand, and then causes the line to snap straight when it exits the collision volume. Although our hand tracking SDK aims to make this process easier, you can of course write your own raycasting implementation scripts if you prefer. To wrap up our tutorial on implementing hand tracking and interactions in your application, let's take a look at how the train application is taking care of object interactions with near-field items. We already know that the Interactable Tools SDK driver is handling the addition of interactable tools to each object, and that the Hands Manager is routing interactions to each hand and deciphering whether it is distance or near-field. Now, let's take a look at how the near-field objects are configured. In Unity's hierarchy window, navigate to Scene Setup and expand it. Next, open the near-field items and all geo. We took a quick look at these earlier, but let's jump back to them and have a look a little bit closer. Each of these game objects has a few children. The children that we are interested in are button proximity, button contact, and button action. Each of these objects is calculating its proximity depths and activation depths, and then reporting them to their parent button. Each time the user's hands enter one of these volumes, the state of the button is changed to the appropriate label: proximity, contact, or action. When it finally enters the action state, the appropriate method is fired by the event on the button housing. The methods that are selected are all contained on the controller box game object inside the controller box controller script. You should recognize the amount of feedback being given to you as you interact with the buttons in this application. When your appropriate finger, in this case hand-finger.index, enters the proximity zone, the button is highlighted with a yellow glow. When you contact the button, it turns yellow to indicate that your finger is in fact touching the button. Finally, when you push the button, you see the button push in and the color flashes to white during the push interaction. These are all visual cues triggered as your tracked finger enters the various volumes shown on the button. Whether you decide to write your own interaction tool or use the one provided by Oculus, it is important to consider accurate ways to give users feedback to ensure their experience with your VR app is as smooth as possible. Well, congratulations! You've completed this tutorial. If you followed along, you should feel comfortable implementing hands into your application and be able to implement world interactions tied to world space objects near and far. You should also be ready to identify and tackle obstacles that hand tracking may present to your users. We're very excited to see the new projects you'll develop using this exciting feature for Oculus VR applications.